Hello, and welcome to our virtual Lunch and Learn. Today we're talking about Fieldbus, the hidden Ethernet frontier. My name is Leanne Ireland, and I'm the Corporate Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Mike Vermeer, Engineering Strategy Manager from Panduit Corporation. Out in the comments section, ready to answer your questions, is Jim I can't say it. I'm so sorry. Now it's stuck. From Panduit, and Tom Voltis from our Madison Heights location. We'll also have a Q&A portion at the end for Mike to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. We're happy to be able to host these live sessions on YouTube, making it possible for you to be able to join us from the comfort and safety of your own homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. Be sure to join us every Wednesday on your lunch break. For anyone just joining us, welcome to our virtual Lunch and Learn. Fieldbus, the hidden Ethernet frontier. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comments while our presenter, Mike, talks about the challenges to data accessibility in critical applications, including building automation, process automation, and industrial manufacturing. Our specialists, Jim and Tom, will do their best to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Mike's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you have. If you'd like to reach out afterward, or if you have further questions for Mike, you can send us an email at macandmaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Mike. We'll have that email address on the screen for you at the end as well. It looks like we have quite a few attendees now, so let's get started. Mike, I'll pass it over to you now, and hopefully you can say Jim's last name since I butchered it. Sorry about that.
No problem. Thank you. Thank you, Leanne. As she noted, I'm Mike Vermeer, Engineering Strategy Manager at Panduit, and I want to give a special thanks to Tom Voltis and Jim Danagelis, who are our moderators for this session. Tom is with Mac and Mac as an OT network consultant, and Jim Danagelis is an industrial account specialist with Panduit in the Great Lakes region. So thank you both, and feel free to chat with them as you have questions, and we can also have some discussion at the end. So thanks again. What I'd like to talk about today is a very new topic. It's been years in the making, but the exciting thing is this year, 2021, really single-pair Ethernet is coming into its own with some pretty exciting applications in industrial. And the exciting thing is not only does it have new applications that are coming in the market today, but single-pair Ethernet forms a foundation to transition a lot of different technologies that historically have not transitioned to Ethernet. Helps Ethernet, it helps these Fieldbus applications transition to Ethernet onto a physical layer technology that really was built for Fieldbus. So we're going to talk about single-pair Ethernet as an opportunity for Fieldbus as it applies to topology and comparing and contrasting single-pair Ethernet topologies over against Fieldbus and what we typically know of Ethernet today. We'll do the same with security, and we'll also look at power and edge versus gateway applications. And then A couple next steps for single-pair Ethernet, and what I'm really excited about is to share a little bit about process automation and what great work a group known as Ethernet APL has done in applying single-pair Ethernet to some very specific needs in the process industry. So we'll start with some general overview and foundation of single-pair Ethernet, and then go into a little more specifics about process automation. Now, the important thing when we look at Ethernet and the growth and expansion of Ethernet in the market in data centers and enterprise and building automation or in industrial automation, it's risky to look at single-pair Ethernet as a part of the overall Ethernet growth. And we've seen it grow from 10 base T, 100 base T to gigabit and multi-gigabit speeds, and the world has changed based on the vision that we've been able to go with much faster, much higher speeds, longer distances, fiber optics. And the powers of 10 video that I'm showing the snapshots of really capture the changes that have taken place in communications over the past decades. This is a video that was developed decades ago by Charles and Ray Eames for IBM, and it just shows perspective on the photographic scale that I thought had a good transition, had a good correlation to the growth of Ethernet. And what was most meaningful to me is not only it goes to the farthest out, but with Ethernet, the risk that we have is to always and only look faster, farther, better from a raw technology standpoint. And if we only take that perspective of stretching the technological limits of Ethernet to go faster, further, the problem is we leave a lot of different applications behind. And the powers of 10 video also shows that when it goes down, it goes out to the light year scale, but then it goes down into the negative powers of 10 and angstrom scale. So we have to realize that as we look farther, faster, more technological capability, we're leaving behind some of the small scale applications for Ethernet and the value of Ethernet really in the Fieldbus area. So wanted to talk a little bit about that and the future of Fieldbus as admittedly different future, admittedly different frontier than we've typically looked at for Ethernet, because we're focused on not faster speeds, but actually slower speeds, and not your traditional Ethernet, but pretty non-traditional. But this frontier is not unknown to us. A lot of these devices we've seen today in our intelligent building that we sit in for work, and the lights and shades and access control and smart HVAC systems, also in process plants and intelligent factories, sensors. These systems, in large part, do not use Ethernet, but have a whole potpourri of different types of technologies that have grown organically based on the needs of customers and applications. So you might have sensors that used to and still sometimes communicate via 0 to 10 volt signal, and that has evolved into Fieldbus technologies, some lower level Fieldbus technologies such as HART and IO-Link, into more advanced and more complex technologies like RS-485 and their applications over BACnet and Profibus and Ethernet IP or DeviceNet. And then some of these application layers built into Ethernet-based protocols, but we still see quite a few Fieldbus systems, especially in smart buildings and process plants and in automated warehousing and factories, and we have to ask the question, why have these systems not converged onto Ethernet where so many other different applications have? And what I want to show in this brief discussion is how single-pair Ethernet was built, and built with these applications in mind, so that device vendors can begin to think through how they deploy single-pair Ethernet in their devices, and how end users can think about the impact that that can have to them deploying and maintaining an intelligent building. So first of all, the basics of single-pair Ethernet. Again, the risk is we compare single-pair Ethernet to your traditional base T, 10, 100, 1000, and gigabit and multi-gig Ethernet. That's a risk because with single-pair Ethernet, we're going down a level in terms of capability for bandwidth, and looking instead at comparing it to Fieldbus applications, and they have different capability around length, around simplicity of deployment, and related capabilities. So single-pair Ethernet has two main functions, two main standards: 10 base T1L and 10 base T1S. We're going to focus most on 10 base T1L, which allows for 10 megabit per second full duplex communication over a full kilometer length. And this 10 base T1L, it also has a capability for power, corollary to power over Ethernet, known as single pair power over Ethernet, or SPOE, otherwise known as power over data line. It only uses 2 conductors, and there are multiple options for connectors, some standardized and some like screw terminals or IDC connectors. So you can see this is very different from base T Ethernet, which only goes 100 meters in a structured link and is standardized on that. The bit rate is anywhere from 10 megabit per second all the way to 10 gigabit per second, also with full duplex. Power delivery has expanded over the years. Now we're up to 90 watts power delivery over all the up to 8 conductors or four twisted pairs. And the ubiquitous RJ45 connector, that's the most common, although there are many different connector options. You might look at an Xcode or decode M8 or M12, I should say, M12 connectors, and there are various other connectors. RJ45 is the most common. We're not looking with single pair Ethernet, we're really not looking at changing from RJ45 and 10, 100, 1000 Ethernet and going to single pair Ethernet. The reason is the Ethernet that's deployed in the plant is purpose built for the applications that it's being used for. It's used in industrial quite extensively in the upper levels of the plant, in the control and in the management parts of the network. It's used and almost ubiquitous in the data center and in the enterprise. Ethernet goes to every desk, every application, goes to video cameras, goes to many different applications, and base T Ethernet is really built and well suited for those applications. Single pair Ethernet isn't built for those. What single pair Ethernet was built to accommodate and to recognize is the many different Fieldbus applications like Profibus PA, like Modbus, CAN bus, IO Link, and other applications that allow for much longer distances and have various requirements, but only deliver a very small bandwidth, 31.25 kilobit for Profibus and some of these applications, sometimes much lower when you're looking at 4 to 20 IO Link and HART applications. So really, we're looking at making those physical layers, making those applications, giving those the tools that they need to migrate onto an Ethernet system. So let's look at a number of different applications. First of all, topologies for single pair Ethernet. With 10 base T1L, SinglePair Ethernet 10BASE-T1L delivers up to 1 kilometer over a single structured link. So you're not looking at just a cable, but you're looking at a structured link, and you can measure the performance of the entire structured link. So the idea is you can put, just like you put in a 100-meter 4-pair Ethernet system and it's tested and validated and warranted, now you can put in a full kilometer structured link, single pair, and test and validate it for 10BASE-T1L communications. The reason for up to 10 structured cabling links is because you don't want to pull necessarily a full kilometer of cable. That can get tedious, it can get difficult, and can put a strain on the conductors. So giving you room to pull maybe 100 meters at a time, maybe 200 meters at a time, gives you some capability for that. And then with the entire structured link, you can evaluate the performance to deliver not kilobit per second, but 10 megabit per second performance over that link. 10BASE-T1S is a multi-drop technology, which we haven't seen for quite some time with Ethernet. It delivers 10BASE full duplex 10 megabit per second performance, but instead of going a full kilometer, now you're going a limited 25 meters and can put up to 8 devices trunking into that single twisted pair. So it makes it simple to connect multiple devices in a short range. So you can think of applications like a control panel or machine, where now instead of putting a switch on the machine, you can potentially bring just a single connection to that machine and connect everything via that connection, get your 10 megabit per second performance, and simplify your system. That could also be deployed, that multi-drop type segment, it could also be deployed with T1L. It would make the devices a little more complex because now, similar to what you've seen with, say, device level ring, you could deploy a 3-port switch into the device and use T1L communications. The disadvantage to either of those is power. You can't power everything always with this type of structure because 10 devices or 50 watts might not be enough for that. But overall, there are opportunities here that we can develop and drastically simplify the massive number of devices that are connected onto the network. We don't need to have individual switch ports for every device, every sensor on the network now. So when we talk about security, typically over the past decade, the OT, operation technology security, for the plant Ethernet network typically falls under the IT organization or a subset of IT that's focused on the plant itself. This has improved massively over the last decade with rules around security being deployed as it has been deployed in the enterprise network, deployed in the manufacturing network, with upgrades, with patching. It's improved quite a bit, and there's been a lot more interplay between OT and IT around security, around updates, around working together in the context of we need the plant to stay up and running. We also need the data in the plant to be secure. Below the PLC, the Ethernet network that is the downlink from the PLC and that is separate from the plant Ethernet network, that's also improving. We have tools that allow us to monitor and track the full stack of the Ethernet network below the PLC. Non-Ethernet communications, though, typically aren't secured actively and monitored. These are old technologies. Some of them don't really have a capability to be encrypted. And so security is pretty weak for these, and typically we need to be careful about who has access to the plant in order to maintain security of these systems. Once you implement Ethernet, really what you are able to deploy is security end-to-end from the application layer all the way down to the physical layer with encryption and monitoring and routing and just enable the full stack of security. So while on the OT side, with the traditional protocols, with the protocols that have been in place for the last multiple decades, you have a gap on security. As we deploy Ethernet lower and lower in the ecosystem, in the architecture, the full stack security almost comes automatically. It becomes an automatic win for the deployment as a benefit for single pair Ethernet. It's important too to realize that when we're talking about the Ethernet network in the plant, we're talking about the nerve endings of the building, and these connections are typically accessible inside of the plant. So being accessible, they're also the most vulnerable connection to security risks, especially physical security risks and accessibility. Power is an interesting and a great opportunity for OT networks. Typically, we're distributing AC power throughout the plant, and then we'll distribute, connect to the devices and provide power from power supplies that are distributed through the plant. Every control panel will have the power supplies that support the plant, and then the data connection into these devices is going to be separate. This is done pretty much everywhere. As the more technology, more computing goes into these devices, a lot of the controls devices now are powered by DC. And so the question becomes, could it be more efficient to operate these devices over centralized DC, a centralized DC power provided out to a DC power grid? For applications where that makes sense, single pair power over Ethernet provides the ability to do that. You can deploy a power grid, a DC power grid, using single pair power over Ethernet, which provides up to 52 watts of an intelligent power and data onto the system. It's not it's not fit for every application, but there are certain applications where it makes sense to provide DC power and centralize the AC to DC conversion instead of distributing power supplies throughout all the building. I think of, for example, the dozens of AC to USB transformers that I have in my personal office, and that can translate into many different applications. And then even better is if we can look at the sustainability aspect. And for example, solar power, which could be generated on many buildings, that solar power, in order for it to be useful in today's buildings, needs to be converted from DC to AC, where it can be distributed throughout the building, and then from that converted back to DC, where it can be used. So if we have a DC power grid, solar power could much more efficiently be used instead of converting, doing the dual conversion from AC and then back to DC. Then finally, thinking about what data has to go through. If you look at a typical sensor, say a temperature sensor in the plant, that often is going to be a very basic sensor, uses 0 to 10 volt signal to convert, or 4 to 20 milliamp to identify what the temperature is by delivering a voltage or a current signal onto the wire. And then that'll send out to an I/O card or a gateway that reads the voltage or the current on the wire, converts it to temperature, and then contextualizes that as what does this mean? And then from there, the I/O card is programmed to convert back to MQTT or some other protocol, packetize, send it to the controller that interprets the data and uses it, and maybe makes some decisions based on it, and sends out some other signals. That has to happen, and that has to be programmed into the system versus if that sensor was connected and powered by single pair Ethernet, now instead of all the programming that's required to read and contextualize and send that data out, the sensor can simply be delivering that data on a publish subscribe mechanism into the controllers, into the cloud applications. Whatever applications need to have this data can interpret, or can receive and interpret and use that data for their applications. It doesn't need to be it doesn't need to be an application where you have to shut down the PLC, gather the data, and build out your custom system and gather the data as a kind of a unique application. You can use that data from the sensor for whatever applications that you need it for. So those are some comparisons from SinglePair to Fieldbus and some ideas that we have for implementing a more intelligent Fieldbus in a way that is reminiscent of and uses very similar architecture to 4-pair or to the Fieldbus systems that are in place. Now, as we look at the deployment of single-pair Ethernet, there are many different types of connectors, infrastructure that can be used to deploy it. I want you to think about the 2- and 4-pair connectivity that's used today and realize there are a lot of different versions. You have shielded, you have unshielded for various applications. You have M12, Xcode, and decode for sealed applications. And similar to that 2- and 4-pair context, single-pair is going to have its own variations of connectivity, where in some applications, you're going to have screw terminal or M12 or M8 applications in industrial machine environments and outdoor applications. And for industrial machine and building control panel applications, you might have a shielded, whereas plenum building automation, you might have unshielded applications. The IEC has landed on, for especially the IP20 application, and IEC 63171-1 or type 1 connector, which is reminiscent of the LC style connectivity and just makes it very easy to deploy 2-wire connectivity, plug and unplug it in. You don't have to worry about screw terminals and screwing in and unscrewing connections. So it's just a simple way to deploy single-pair Ethernet connectivity, and these are standards that are being developed and are beginning to be used and for deployment, both for the structured cabling system as well as for the device connectivity. Panduit's launched single-pair Ethernet connectivity for Type 1. It is for IP20 applications. This is a shielded version with an unshielded option coming. It's based on IEC 63171 Type 1, RoHS compliant, a wide operating range, and focused on multiple mating, unmating cycles, and compatible for 18 gauge and will range from 18 all the way up to 26 gauge options. So this is it's a pretty new connector. It's a new standard that's been released by the IEC and will become one of the common connectors used for single-pair Ethernet. When we look at industrial applications, know that also M12 and M8 A-code will probably be a common standard that's used. It's already been recognized by a number of vendors in the APL. I'll show you a little bit about that. This is 18 gauge compatible for what Panduit is releasing, but there's nothing unique here aside from we're using M8 and M12 A-code systems. So the benefit is you don't have to completely change your systems. As you deploy single-pair Ethernet, we can transition from your Fieldbus systems into a single-pair Ethernet context. There's a lot of similarity between your Fieldbus connectivity and cable and your single-pair Ethernet cable and connectivity. And what you're looking at here is a single-pair Ethernet cable. IEC 61156-13 is a relatively new standard around the deployment of single-pair Ethernet and defining the cable needed. We're expecting foil braid and drain in certain circumstances for terminating onto a terminal block, but it's very similar in its construction to IEC 61158-2 and you'll see a lot of similarities between the two, and probably linkages to show compatibility between these different systems. For full kilometer reach, we're expecting a need for about 18 gauge conductors. And as you go smaller, we expect smaller gauge. So 23 gauge for 400 meters and shorter lengths for 26 gauge conductors. And you'll note that when you look at single pair Ethernet cable, it looks almost identical to the cable that you're using for Fieldbus. So Profibus, aside from some color, you're using the same 22 or 22 or 18 gauge conductors, shielded and foiled braid, and 100 ohm impedance. Same for foundation Fieldbus and BACnet MSTP. You're seeing the same thing, and the reason why you're seeing so many similarities between these is they're all based on RS-45 communication technology, and RS-45 communication technology. I said that kind of fast. RS-485, 485 communications is really what single pair Ethernet is targeting as the next evolution of Fieldbus for those systems that use RS-485. You can expect single pair Ethernet has more stringent requirements because it's operating at a much higher frequency. In most cases, it's going to be backwards compatible. And what you can expect is there's going to be a base level of capability. For these Fieldbus cables, there's going to be a way to test those cables and evaluate their performance for single pair Ethernet. And the opportunity that you have really is then to look at your future applications as you're deploying Fieldbus in your building or in your process automation plant or in your warehouse. Look at how you're deploying Fieldbus, non-Ethernet capability, not Ethernet protocols, and look at the opportunity that you have to deploy single pair Ethernet capable cable to operate that Fieldbus. It's going to take a couple of years for all of the devices in process automation, in warehouse automation, in building automation to evolve towards single pair Ethernet. But it is an inevitable move that these systems take advantage of the benefits of Ethernet as converging the entire system, the entire plant, the entire building into Ethernet where it can be managed as one system. That's an inevitability. And by putting in Ethernet-based infrastructure, you can drastically improve your ROI, your future ROI for deploying those more intelligent systems in the future. So as we expect in building automation, we expect use cases around single pair Ethernet conversion and the use of PoE in the building industry for more of the building automation applications to converge onto Ethernet using the simplicity of single pair Ethernet. The advantage that we have is the application layers are already built. So what is typically used as BACnet MSTP in building automation, BACnet already has an IP variant with BACnet over IP. So this is a conversion that is really, we're talking about a physical layer conversion. The application layer is already built. And then what I want to get into now is some opportunities in industrial automation that is starting with the process industry. And there's an organization known as Ethernet APL, which really is a new organization, but is a combination of and partnership between the Foundation Fieldbus Fieldcom Group, ODVA, the OPC Foundation, Profibus, Profinet International. They're all working together and with the leading controls vendors in the market to take single pair Ethernet and apply it to the process automation applications. The unique opportunity we have here is based on who's involved with this, we can expect, as it's applied to process industry, we can expect these systems to trickle into discrete applications and other automation applications. So give me a few minutes and let's talk a little bit about Ethernet APL. So within process plants, the trend is to take all of the data, all of the systems in a process environment, whether it's chemical processing, food and beverage processing, oil and gas, or the power industry, various parts of process automation. We're generating data all over the place. Level data, temperature data, pH, flow, pressure. All of this data historically has been very centralized into specific systems that had very tight control and were controlled on premise into discrete systems. Over the last decade, these systems are trending towards networking of everything, centralize the data availability so that you can centralize the analysis, so you can also centralize and collaborate around the performance, and really build more potential into the plant, build more capability into the plant based on more accessibility and more awareness of what's going on versus everything being locked into a specific system. Now, the technologies used in the field, historically starting with analog and pneumatic control, and over the years have evolved into low-speed digital like HART and the HART communication technology over 4 to 20 milliamp that has been adopted throughout the process industry, and then that going into higher speed digital Fieldbus like Profibus, Foundation Fieldbus, and other Fieldbus technologies. And then the desire to move into Ethernet, and that's been a desire, and it's begun to move in the process industry towards Ethernet. But then the benefit of that is as you get more intelligent in your physical layer technology and how that technology is being delivered or being used and the data is being delivered, you can more integrate how the data can be used. So with pneumatic and analog, you can't get access to this data remotely, and often locally it's difficult. As we get into digital field buses, you can get the data. Typically, gateways required to convert the data from its digital communication into Ethernet and then send it into the cloud, which gateways require special programming. When it's in Ethernet, all of that is integrated, and you can get much easier access into the data. So Ethernet, it's made massive progress in discrete automation, and I've said before, it's grown from over the last 10 years up to I think 65% of Fieldbus in discrete automation is already Ethernet, 4-pair, 2-pair Ethernet. So there's a great advantage of doing so, but in process plants, it's not covered. It's not being used in process plants except for some very specific applications. And the reasons why is in process plants, they need longer distances. They need technology that's easy to handle. They need harsh connectivity. And most importantly, they need to meet the requirements of explosive environments. And everything in the process industry is built around supporting those explosive environments. And because of that, in the field, you're only using serial bus or analog connectivity. Well, in the control, supervisory, and management parts of the network, you are able to use Ethernet. So the goal is to move from there to a situation where we can use Ethernet from the enterprise all the way down into the field, into the connectivity in the plant. That was the goal of the Ethernet APL organization, to make concurrent access for everything from the field all the way into the enterprise without requiring gateways, and providing future-proof capabilities around cybersecurity and safety in applications such as that, as well as making the deployment simpler. So I talked a little bit about the organizations. So the benefit that we can receive is we don't need to build a new application layer. We can take advantage of the application layers, Profinet, Heart IP, OPC, Ethernet IP, and put those IP technologies onto the Ethernet physical layer if we can make the physical layer be able to support the needs of the process industry. And that means the infrastructure used. We need to look at the infrastructure used at the process industry. We have to look at the power requirements of the process industry, and we have to look at the intrinsic safety requirements of the process industry. So let's look at some of those. Just to emphasize, Ethernet APL and SinglePair Ethernet are a physical layer. We aren't touching the rest of the stack. We're still using data link, network, transport layer, and we're still using the application layers that we just described. We're talking about just another physical layer for the process plant. Explosion protection in the process industry is being developed using what's known as 2WISE or two-wire intrinsic safe Ethernet. That standard provides device interoperability, and it makes much simpler the planning and installation rules and validation for intrinsic safe applications. So the validation of these things is much simpler. Because of this, because of two-wire intrinsic safe Ethernet operating over single-pair Ethernet, we can be confident in deploying, and the standards bodies and regulative bodies can allow the use of Ethernet in the process plant. What it looks like for single-pair or for Ethernet APL is you start with facility Ethernet. That's your 4-pair communication, and we're currently using this class 1 div 2 type applications for 4-pair and 2-pair Ethernet. That's in place today. Then from there, we go to a trunk, your 1,000-meter trunk, which is a single-pair Ethernet communication that goes out to a field switch. And what's really important is that spur that goes from the field switch, because this spur goes down to the intrinsic safe, the most critical intrinsic safe applications, and provides power limiting and the 2-wire intrinsic safe Ethernet to that instrumentation. So the trunk provides up to 1,000 meters, and the spur can go up to 200 meters. So you're really matching what your Fieldbus systems have provided before for single-pair Ethernet or for Fieldbus applications. And then your cable for single-pair Ethernet is going to look a lot like the cable that was used before for Fieldbus, and a lot like the cable that I described for single-pair Ethernet. So there are some common utilizations for color, light blue sheath, when deploying cable and intrinsic safe applications, control cable and intrinsic safe applications. There's common red and green for the conductors. Otherwise, we're looking at 100 ohm cable, shielded, foiled cable, and your traditional Fieldbus and single-pair Ethernet applications are very similar. The terminations are very commonly screw terminals or terminal blocks in process applications, and also Ethernet APL allows for M8 and M12 connectivity, or traditional M8 and M12 connectivity, and that would be nothing new for single-pair Ethernet. So we're still talking the same language as Fieldbus, but applying it to the use of Ethernet. So here's another view of a topology, a star topology with spur segments. So we can look at it in terms of the zones and divisions, safety zones and divisions. So the spurs can go into zone 0 and zone 1 applications. Your traditional single-pair Ethernet and 4-pair Ethernet can go into the higher level and less critical applications, intrinsic safe environments. So the benefits that you get out of Ethernet APL, first of all, you don't have with traditional Ethernet. Traditional Ethernet does not offer intrinsic safe without extreme, very careful implementation. In the process industry, customers have a desire for polarity independence, which you cannot get with Ethernet, 100 base T Ethernet. And then compared to 4 to 20 milliamp with HART or Fieldbus, you're always going to need to use gateways in those applications, meaning the data accessibility is always going to require some more programming. So single-pair Ethernet over Ethernet APL checks all of these boxes and really provides a massive advantage in the process industry for upgrading their systems and making their systems ready for deployment of these technologies as devices become available. And then as we go, I just want to emphasize what you're seeing is the edge of the leading edge of process automation technology, communication technology, and Fieldbus, and this is a great opportunity to really begin to converge the systems to make the overall plant much easier to manage and provide data up into the cloud in a seamless way. It's brand new, but there are devices on the market now and available from the vendors that are part of Ethernet APL. We have devices available from vendors like Panduit. We have cable and connectivity available that can help you deploy the overall system and really provides a next step in where the future is going in terms of Fieldbus technology. So just want to highlight the great work and development by the Ethernet APL organization to take this step and to bring Ethernet into the process industry and into the Fieldbus. I encourage you to look at ethernetapl.org, and also I encourage you to attend Automation Fair, and at Automation Fair you'll be able to see a lot of this in action and some more discussion about the future of Fieldbus over single-pair Ethernet and Ethernet APL. So that's what I wanted to present today. Thanks for your attention. Thanks for your patience, and open to taking questions as there are any, and look forward to continuing to drive this forward with you.
Thanks, Mike. That was great. So we don't have any questions right now, but I do have a couple questions that maybe you could answer for me.
Sure.
Will the single pair Ethernet support the Ethernet IP?
Yeah, Ethernet IP protocol by ODVA, and really any other application layer protocol. There's no reason that single pair Ethernet cannot support any of those application layer protocols. So ODVA being a part of the Ethernet APL consortium and actively working on that as a physical layer, customers can be confident that Ethernet APL and single pair Ethernet as a physical layer will be supported by Ethernet IP is what I would expect. And you can, for definitive response on that, definitely ping the ODVA and their single pair Ethernet subcommittee on the roadmap for that support.
And are these switches on the market? Are the switches on the market that support the single pair Ethernet?
Yeah, what customers can expect is there are switches in the market today. I believe Pepperl & Fuchs launched a switch for single pair Ethernet focused on process automation, and there may be others. You can definitely expect both switches and 4-pair to single pair Ethernet converters to make single pair Ethernet accessible. And there are some on the market already today.
How is it possible to transition from Fieldbus to Ethernet protocol?
Again, I would encourage any customer that is deploying Fieldbus today to think critically about what the future of that Fieldbus system is, what the life expectancy of that system is, the upgrade path over the next 20 years. And it could be very efficient for them to deploy single-pair Ethernet systems in a way, single-pair Ethernet systems and infrastructure that's backwards compatible to whether it's a process or discrete or building automation applications. I would encourage them to look at the use of single-pair Ethernet in order to future-proof their Fieldbus application. So deploy single-pair Ethernet cable in as much as that cable can support the needs of Fieldbus, which often it can. Any other questions, Leanne?
Not right now, but while we wait to see if anyone has any follow-up questions, I'd like to reiterate that you can reach out to us even after this live stream has ended at macandmaclive@mc-mc.com. We'll make sure that your question is passed along to Mike, who can respond to you directly. Just be sure to let us know the name of this session in your email.
Yeah, and I forgot to mention, there's also a page, a web page that you can look at, panduit.com/single-pair Ethernet, all one word. That page will have a lot of the material available, some that has been described here, some new, and providing roadmaps for customers for where they can go, how they can think through their future and their planning of their next Fieldbus systems.
That's great information. We do have that in the description for this lunch and learn. Doesn't look like we have any more questions. So I just want to thank you, Mike, and thanks Jim and Tom for sitting out in the comment section. Thank all of our live viewers for your time today. We hope this session was informative and engaging for you. If you've not already subscribed to the McNaughton-McKay YouTube channel, please do so for more industry content. And we look forward to seeing you live again next week. Have a great day.